So I'm still waiting for those students that did not send me some work. Please send it to me. I will accept it for a full credit. So don't worry, just make sure you email it to me. I actually got a makeup, I guess, couple of makeups, and I raised the grade as I promised by one. So instead of C, I gave B, or instead of B, I gave A. I think it helps. It's all on Canvas. So please check Canvas, see if you like your grade. The main grade is called course grade. Course grade is the key part. That's what you are getting on this class. There is a midterm grade, there is a homework. Later there'll be a final grade, but the key grade is a course grade. That's what you should look at. Now, I'm not sure Canvas sometimes gives some percentages, some points. It's not me, it's Canvas. So don't look at that. Only look at the course grade. And course grade could be either A or B or C or D, no minuses, no pluses. So if it's A minus, it means you still got A. It's a little A, but it's still an A. It's not a B. But B plus, it's still B. So I give you a plus to hint you that you can still fix it. And that's why I keep reminding you about this turning in work, emailing me whatever you like to email to do the makeup if you want to. If you want to increase your course grade, which I never mind you doing. So keep that in mind, and you still have time. And I don't set the deadline, but it'd be good if you send it to me within this week or next week, because the time is running by. We have what 5 more weeks of class, and that's it. And there'll be a final, and after that, we should be done. So, anyways, let's recap what we did last time, because this is a very different section with everything we did so far, and I wanna not to hurry with it. It turns out this stuff is leading you into Calculus 2 class and some proofs that you see into Calculus 1 class as well, but that'd be later. So right now we're discussing sequences, sorry, sequences. They're infinite sequences. So they continue forever. So they just say dot, dot, dot. It means that we have first term, second, third, fourth, fifth, sixth, seven, and you can do this till the rest of your life. Just millions, billions, trillions, and so forth. And there'll be more and more and more and more terms. So they're infinitely long. And that's what sequence is. And that's important to realize. So it's infinite. But you can count it. You start someplace at first term, and then you go second, third, fourth, etc. So that's what we considered last time, and it's always a good idea to have the so-called nth term formula. So this way you don't have to start in the beginning. Like here, you see the first term is e to the first over 1, second is e to the second over 2, e to the third over 3, then hundredths term will be probably e to the power of 100 divided by 100, since this is, I guess, pretty straightforward way to produce terms. You can even guess whatever term you need. Billions will be probably e to the power of billion over a billion, etc. So you have this little terms of the sequence, and you can always produce the next and the next and the next. But it's not always that straightforward, and that's why people like to produce the formula. In fact, when I saw the formula right away, I was able to produce hundredths term. And sometimes you need to do a little algebra to produce the next term. And here, for example, you have a sequence with so-called sign alternating terms. So this -1 to the power means that one term is positive, the other is negative. Next term will be positive, the other will be negative. So you will have alternation in sign. That's all this -1 to the power stands for. And it's always like that, so you don't need to panic. So I see it someplace else, I will right away see that that's plus, minus, plus, minus. Or sometimes it starts with minus, plus, minus, plus. It depends, because here, for example, the power is n minus 1, and notice the first term is positive, because when first term we subtract 1 will be 0. So it'll be 0 power, which is always 1. So we start with positive. But sometimes it may be just power of n. So what I'm talking about is minus 1 to the power of n. And that means that we have first term negative because minus 1 to the first power is negative. And then next term will be positive. Next term will be again negative. So they start not with a plus sign like previous example, but with a minus. So the power may be n or n minus 1 or n plus 1, or some people say maybe 2n plus 1. So yeah, whatever way, but usually it's either n or n plus 1. So that's standard, or n minus 1, doesn't really matter, like in this case. So it's for showing that signs will alternate, plus, minus, and so forth. Other thing we saw last time was definition of factorial. Factorial means that you multiply the power, the term n by one less, etc., all the way 3 to 1, all the way to 1. Factorial, that's how we like to write it. And also there was interesting observation that if you use n minus 1 factorial, let's say if n is 3, 3 minus 1 will be 2, right? Then you can actually write this multiplied by n, and that's same as n factorial. And that's what I used last time in a little example when we were able to cancel something. So because n factorial actually is n times n minus 1, n minus 2, and this one starts with n minus 1 and minus 2. So these parts will disappear, but n is a little extra that brings us to n factorial. So that's abstract way to call things, and that's something new, I think, for some people. And well, we should get used to it a little by little. So they look at these factorials and produce various nth terms, and then they get to another totally new thing. They talk about summations. So for example, if you like to add numbers, say 1, 2, 3, all the way, for example, to 10. Well, let me go all the way to 4. You say, so what, Alex? You can just add numbers and you get, what, 10 or something? Yes, you get 10. But we can write this completely differently. We can write this using this special way with a sigma. That's a Greek letter that stands for sum. So I can say that my terms look like letter K, and that K will vary from 1 to 4. So what is going on? What is that you just wrote? Well, my K could be 1. The next will be 2 all the way to 4. Next will be 3, and next will be 4. And this sigma means you add those terms. So you put pluses. So that's the same thing we have above, but written different. I say, why don't you write it like that? Well, why don't you just keep it as sum? Well, it's convenient if you have lots of terms to add. For example, if you have 1,000 numbers to add, how would you add 1,000 numbers? Well, you use this summation notation, and that's how you describe it. Or else you will say 1 plus 2 plus 3 plus 4, and when people get to understand what you're talking about, then you put plus dot 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 all the way plus 1,000. So if you write it like that, I will understand, so that'd be fine with me. But you should be able to read this special notation, so-called summation. And for this special notation, they, of course, coming up with interesting formula. So for instance, they have formula if you add a bunch of numbers all the way to 4. So what they say, you can add 1 and 4 and 2 and 3 first and last. You get 5. And again, you get 5. So you add in 2 5s and you get 10. So basically, if you want to add numbers all the way to 100, so if you're trying to add 1, 2, 3, plus, etc., plus 99, and plus 100, you can use exact same idea, add in first and last, and then the previous terms. So you get to add first term number 1 and the last term, which is number 100. So you get 101, right? And notice that if you put together another pair, such as a 2 and 99, you will get exactly the same 101 again, because the next number is bigger by 1, 2, but the last number is smaller by 1, and that's why their sum is still the same. In other words, to get that sum, you can see how many 101s you have in your sum, and there looks like 100 divided by 2, because that's number of pairs that you have, like a half of them are pairs. So it'd be 50 times 101, and this be something like 5, 0, 5, 0. And the reason I'm talking about this is because they came up with a formula for that here. It's a formula 6 that says you have first term and then n plus 1. So if you look at the first term, which is, last term, which is your n, then the one that follows is n plus 1. Notice that's sum of your last term plus 1, so that's n plus 1. And you multiply, and then you divide this by 100. So that's divide this by 2, because you see the number of pairs. So it's actually a formula, so you don't have to do this every time intuitively, but use this formula. That's quite amazing. So you can utilize this formula to do the exercises. So let me try to do a couple of problems here in this section with this so-called summations. Like, for example, if I try to look at the exercise number 49, so I'm looking at exercise in the section 12.1. That's a new chapter 12. First section of it is 12.1. So things look kind of unusual. So you have the sum of k plus 2, and it varies from 1 through n. Let me magnify this a little bit so you can better see this. I think it's still n, right? Yeah, up to n. Okay. Okay, so let us add numbers up to n. How can I do this? Well, not just recall the formula. I think I didn't try it, but I can definitely remember it. So when you provide it with a formula, the problem is actually solved. All you need is just to put numbers in that formula. So again, it says that sum of k's. Well, I can put some other letter. Let's say I, that's not a popular letter to use. That varies from 1 to n is going to be the product of n and n plus 1 over 2, right? That's how the formula looks like. Or you can put n plus 1 in the first place, doesn't matter. So in this formula, now what I should do is see how this could be changed with a k plus 2. So how can I utilize, instead of I, k plus 2? So how can this be done? Well, let me first try to write down what this means, where we actually start and where we end. So it looks like k plus 2. So if k is 1, then 1 plus 2, right, will be 3. So my first term is 3. The next term will be 2 plus 2, so it'll be 4, right? It looks like we keep adding 1, but we don't start at the beginning at number 1. We start at 3. So where do we end? What's our last number? Well, looks like if I replace k with letter n, right, it's going to be n plus 2. So basically, what I need is add numbers all the way up to n plus 2. But if I do that, so if I add from 1 to n plus 2, I'm going to have a couple of extra numbers. They will be always starting with number 1, right? Then number 2. And then there'll be starting what I really need, because mine starts at 3. So then it'd be 3 and then 4. So you need to do a little shift or throw away something from your sum, because you're basically going all the way to n plus 2 to the end. So I can use the formula for that, right? But to get to what I need, I'm going to have to use that. So I need to use from 1 to n plus 2. But subtract these two guys. So I need to subtract 3. Right? So that's what I have to find. I need to find the sum from 1, because that's what we have a formula for. And if I find the sum from 1, I'll get a little extra, because I'll have these two extra numbers we don't have here. So I need to take them away. And these two numbers, 1 plus 2 is 3. So I need to drop 3 from that sum. So how do I find that sum? Well, the formula above is waiting. So instead of n, I just need to put n plus 2. So in my first position, I put n plus 2. In my second position, second factor in that fraction will be n plus 1. So now it's n plus 2 that I have to increase by 1, right? So Alex plus 1. So, okay, I put plus 1. And then divide this by 2. And then I need to subtract number 3. So what I get is a fraction, which is a product of n plus 2 and n plus 3. I'll just write it like that, because technically you can multiply n plus 2 by n plus 3, get some kind of n squared plus 5n, but it's not really going to help you, so you just leave it like product here. That's fine. Practice more. See, I've been practicing. I think I improved a little bit of my writing on this new computer, because the old one I have no longer operational. Over 2, and then I need to minus 3. And that will be the answer. And technically, yes, you could find common denominator. Maybe you'll do a little bit of algebra on that. But our goal is not to get into algebra. Our goal is to get into this new story of summation and how to understand what they're talking about. So with this formula, everything is nice. Other thing we did last time was to get that nth term and then work it out, and problems like starting with exercise 15, 16, maybe I can do one exercise from that group. See, that's something new. That's why I don't want to hurry with this, because I'm sure that's something that you want to get used to a little bit better. Let me try 19. It says recommended exercise with this little pencil next to. So what they talk about is a -1 to the power of n plus 1, looks like an exercise number 15, and then multiplied by n cube, right? Please correct me if I'm wrong. It's power n plus 1, and it's multiplied by n cube. So basically, those are cubes of numbers, such as 1 cube, 2 cube, 3 cube. So that'd be like 1, 2 cube is 8, 3 cube is 3 times 3 times 3, 27. 4 cube is 64, right? 4 times 4, 16 times 4. Looks like it's 64. 5 cube is 125, but they alternate in signs. So we need to carefully put signs in between of these numbers. So what will be sign of the first one, plus or minus? Well, if n is equal to 1, so the first will be 1 plus 1, which is 2, right? So -1 will be raised to the power of 2, so it'd be positive. So next will be negative, next will be positive. I say you put plus 27 or just 27. Well, to be clear, I put plus, minus, and so forth. So sign alternation. So I don't want to think too hard about this power of -1, but I should be a little bit careful. I should be careful with the sign of the first, plus or minus. You can check the second. So second will be when n is 2, is be 2 plus 1, which is 3. And if you raise 1 to power of 3, that will be negative, right? If you raise -1 to third power, it's negative. So that's why second is negative. So signs change from plus to minus and vice versa, from minus to plus. People say they alternate. And that's about it. That's how we can produce terms of our infinite sequence. Or you may go backwards. Like in exercise 27, they say, how about if you produce the formula for the nth term? So going kind of backwards to what we just did. So if you, instead of describing your nth term by that nice little formula that was given to us, now the question is, find that formula. What if nobody gave you formula but gave you actual sequence? How can you get the formula? Well, if you look at these terms, like 1/2, 2/3, or 3/4, you notice that each term starts to increase, right? The numerator as well as denominator. So if I say that's my first term, I can say A1, and this is A2. Notice that indices 1, 2, 3 are same exact as numerators. So for the nth term, I can say my numerator will be n, because numerator is exact same as the term. See, that's important to realize a relation between the number of term and the actual fraction, or to be exact, fractional numerator, which is the same as my index of that term. And then denominator is 1 bigger, so I can say n plus 1. So I just produced the formula for exercise 27. Notice they like to put this in the braces. You can do that if you want. You don't have to, but for me, it's fine if you write an is equal to that fraction. But if you like to be precise, like in the textbook, to read their notation, they say, well, then you get this braces. How about sign alternating, number 33? Let me try one more here. These exercises, they seem to be kind of the same, but not really. Some of them start to use various other approaches. And my goal is not to go over every single little idea in here, but to give you a general overview of what is going on. So if you have first term 1, then 2, then 3, then 4, then 5, then 6, I can say the terms. So an will be n, right? First term is 1, next term is 2, and so forth. But signs alternate. And that's why I need to have -1 raised to some power. Question is, what power? Is that going to be power of n or n plus 1? I say, what if I put n minus 1, Alex? It doesn't matter. It'd be one either same or kind of one less or one bigger, so the sign will change. So which one should I use, n or n plus 1? Well, let me try and see. If I just put n, then the first term will be negative, right? Because it'll be power of 1, so it'll be -1. Is my term negative or not? My first term, where is it? Oh, here. No, it is not. It's positive. So I put n plus 1. So it's either n or n plus 1, so to keep it simple. Sometimes people put 2n. Sometimes people put n plus n minus 1. But I recommend you use either n or n plus 1. I think it's more straightforward. But of course, one needs to realize how to work with the others. Why not? So that'd be the way to go. And of course, everything is not that straightforward. Like if you, for example, are looking at the exercise like number 32, their fractions and numbers mixed together. So they can come up with all kinds of examples of these little sequences. As I said, I'm not planning to go over every little detail because you can do this for a long, long time. There are all kinds of possibilities. But we'll do one more. 32. It says, take a look at the sequence with the numbers and fractions. So first is 1, and the other is 1/2. Second is 2, no, 3, and next is 1/4, right? So how could I possibly describe that sequence? Turns out, looks like there are like 2 sequences here, right? And I think I saw a nice description in the beginning of section among the exercises. So for even terms and for odd terms, there are different things happen. So you can see that it's just a matter of how you describe it. You can write it with words, but of course, in algebra, we're trying to always use algebraic expressions. So here it is. So if n is odd, so you can say a n term will be the same n if we have odd terms, such as a1, a3, you see index is odd, if n is odd. So for odd cases, one thing happens. For even cases, the other things happen. The other thing will be a reciprocal in the case of n is even. Otherwise, we have evens, and people put these braces here, and they say that's like piecewise defined functions if you ever encounter. So that's description using that brace. So in one case, it's like that, and if it's even, like that. So it's either even or odd, so you get this kind of things. And of course, n cannot be 0 because 1 over 0 is undefined, but n starts always with 1. So that's why we don't worry about this. So it's kind of similar, but here it's opposite. So n is even, then we have that because our sequence here is a little bit different, I guess. It starts with 1/1 and then 2. Now it's 1/2. Yeah. So I think it's worth to look at this sometime before Wednesday and well, just start to get used to these ways of description of things. Well, there are also some other stuff that we'll mention later next time, I think. I don't want to overwhelm you with this notations. I just want to first you to look at it, first time in your life, probably for some people, and not to panic, and then you will start feel better. It turns out that all you care about is what terms you're adding together. So you can be adding squares, you can be adding third powers. We came up with a formula for just 1, 2, 3, 4, 5, but there is a formula for 1 squared, 2 squared, 3 squared, and so forth. And it's not that obvious as the one that I just gave you an intuition into. That formula looks like that. Of course, you don't have to memorize it just to know that it exists. And there is a formula for cubes. And of course, there is a formula for fourth powers and fifth powers, but we never do it here. Here's another intuitive formula. So you have same number added with itself n times. So you take n number of these numbers. So instead of adding it c plus c plus c plus c n times, you just say take c and multiply it by n. So you probably don't even need this formula, but that's another idea. I'm showing it to you so you look at this summation notation again and again, and eventually I hope you're not going to panic when you see it. Say, oh, it's just a sum, it's just a short way to write plus, 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 etc. all the way to the last position. So anyways, these formulas are here also, and I think that's pretty much all they have in here. So next time I plan to do a little bit more of exercises in here, and then we're gonna move on a little bit to the next sections of this chapter, which is quite different, and that's the reason why I think you should not hurry with that. So I guess that'd be pretty much all I wanted to discuss today. I don't give you a quiz. I'm still waiting for people to send me their work. Some people never send me any work at all. So to those people, I give a message, so just send me the work. Otherwise, I'll drop those students from class because if I don't get any work, then I don't want to fail. So I still give you a chance to submit late work. So please think about this. And I'm going to stop recording and see if you have any questions. Please ask.